Okay, this is problem number 12. And 12 also is really a very well-known series, and you should know it. Now, when I say you should know it, could you forget it? Of course you could forget it. But let's write this down, we know. And let's take a look at that. So it's going to be, let's see, x minus x cubed over 3 factorial plus x5 over 5 factorial minus x6 over 6 factorial. Yada, yada, yada. And this, just from memory, I'm going to say the x can be any real number, which means x is between minus infinity and infinity, all right? So it means the radius is infinite, and the interval for this thing is going to be from minus infinity to infinity, all right? Now, they didn't ask the question for us to do it from memory. They asked for us to do the problem. So they want to do f of x equals sine x, and they want the center to be at 0. You start writing derivatives down, and you get f prime. You know what I forgot to do over here? I forgot to write this as a sum. So f of x, let's see, sine x, and the sum for this guy is going to be, let's write this down. I'm still going to start at 0, by the way, because I think it's pretty typical to start at 0. So n equals 0, off to infinity, and then I write down, minus 1. It's an alternating series, so n, and then I get, it looks like odd powers. So I'll write down, looks like 2n plus 1 over 2n plus 1 factorial. Let me just check that out. And am I getting what I'm expecting to get? Well, I get the alternating pattern, certainly, and it's 1, then 3, and then 5. Yeah, it looks, well, you know what? I made a mistake. I just noticed it. Let me get my eraser out. It's good to look back over your work, by the way. I just noticed it. This is not a 6. It's a 7. And I'm glad I say coming from memory, I just write them down. It's foolish. Someone says, why'd you write 6 down? I thought 5 and then 6. I didn't even thinking about it. But anyway, looks good. What are you getting over there? Alternating series. Let's say you're getting odd powers. So 2n plus 1 is an odd power. So you're going to get 1, 3. It's going up by 2, by the way. 5, 7, and the bottom also looks pretty good. All right, let's go through the work. And this is the work I expect that would be expected at this point. So cosine of x, f double prime is going to be minus sine of x. F triple prime is going to be, let's see what that's going to be. That's going to be minus cosine x, right? And then the fourth derivative is going to be what? Sine x. Now, I certainly want to point out what happens over here. It repeats itself, all right? So I'm going to get a sequence of numbers now, and let's write this down. F of 0. What's that going to be? Well, sine of 0 is just 0. F prime at 0 is going to be 1. F double prime at 0 is going to be 0. F triple prime of 0 is going to be minus 1. F4, the fourth derivative at 0, is going to be 0. All right? And it just keeps repeating itself. What do you mean by that is, what's the next number going to be? 1, and then 0, then minus 1, 0. So I got an idea, right? I got an idea now that I can predict this forever. Let me erase this stuff over here. I know the prediction for it. So let's write down the Taylor polynomial centered at 0. So f of x is equal to sine x. And let's write this down. So what's it going to be? You're going to get 0 plus, well, you can get 1, and that's going to be over 1 factorial. And then what do you get? You get, let's see, x minus 0, which is just going to be x over here to the first power. What's the next term going to be? 0 over 2 factorial x squared. What's the next term going to be? Minus 1 over 3 factorial x cubed. And I think you get the idea what's happening over here. What's next going to be? Plus 0 over 4 factorial x to the 4, right? So forth and so on. Got to clean up a little tiny bit, and I'm going to write this as, x. I'm going to keep the 1 there still. So I'm going to put down, let's see, 1 over 1 factorial. That's that done. I'm not going to put these down, by the way. What's the next one going to be? Minus, let's see, 1 over 3 factorial x cubed. What's the next one going to be? And again, it's not written down, but I think you probably know the next one is going to be, let's see, the 4 disappears. Let me see if I did this right. You know what I think? Let's see, 0, 1. Did I do that right? Yeah, I did that. 0, minus, plus, minus. I think I made a mistake. It's not really following a pattern at this point. So did I write these things down correctly? Let's take a look at that. I got the 0, I got the 1, got the 0, and I got the -1, 0. I'm sorry, I'm back at 1 at this case over here. All right, I'll put that down for you. So let's see if we did that. I got 0, I got the 1, I got the 0, I got the -1, I got 0, and this is going to be +1 now. Sorry about that. And that's going to be x5 over 5 factorial. All right? And let's take a look now. Let's write that down. So plus, it's going to be 1 over 5 factorial x to the 5. Again, you can keep marching on if you want, but I start to realize it just keeps repeating itself over and over again. So what's the next one going to be? 1 over 7 factorial x to the 7. All right? Yada, 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 yada. All right? I'm going to write down the sum now. And what's the sum going to look like? Let's take a look at it. I'm going to start at 0. I'm going to go off to infinity. I'm going to put down -1 because it alternates to the nth power. That gives me plus, minus, blah, blah, blah. And then I write down, well, let's see what we're going to write down over here. I'm going to write down, looks like n plus 1 factorial. No, it's not n plus 1 factorial, is it? It's going up by 2. So it's going to be 2n plus 1 factorial. Let me write that down. We'll check it. And what's that going to be? Well, let's see, 2n plus 1 at 0 would be 1. So that's 1 factorial. At 1, it would be 3. That looks good. And then I'll write the x down. That's going to be 2n plus 1. And let's do the ratio test on it. That's going to be limit as n goes to infinity. And I'll write this down completely. N plus 1 times x. Well, it's going to be 2n plus 3 now over 2n plus 3 factorial times the reciprocal now, so it's going to be 2n plus 1 factorial, and then you get -1n, and you're going to get x to the 2n plus 1. All right, I got to do that. That's limit n goes to infinity. Well, the -1, they do cancel off the -1 to the first power, but the absolute value is still 1. Let's do the x's now. So the x, it's 2n plus 3 minus 2n minus 1. So it's going to be x squared. That's relatively simple. And then what do you get? Let's see. We got this factorial thing, right? So I'm looking at it, and I'm starting to realize the bottom would be 2n plus 3. And then you're going to get 2n plus 2. The next factor would be 2n plus 1 factorial, and that would cancel off. And what's this limit over here? Well, for all finite x, it's going to be 0. So what could x be? It can be any number between minus infinity and infinity. All right, so what's the radius for this thing over here? Infinity. What's the interval for this one over here? Minus infinity to infinity. All right, so, you know, I want to make sure I wrote that up here for you. And I think we did, that's number 12, right? Yeah, we wrote that down. Same thing, all right? Same exact thing. But it's work. But again, some of these you remember, you write them down. But I think that the intent of this guide is to practice deriving these series. Thank you.